sketch a graph of the line segment with endpoints at the ordered pairs 5, -2 and 9, -5. Then find the length of this line segment. So the first thing that we need to do is sketch the line. And let's label our endpoints. We'll say that our first point here is x sub 1, y sub 1, and our second point is x sub 2, y sub 2. And it's important to keep these given ordered pairs or these endpoints in mind as we proceed in establishing the scale for the coordinate axes. So looking at our x values, we have 5 and 9. So that means that each one of these tick lengths needs to have a unit length of 2. So that way we can see the points. Then looking at the y values, we have -2 and 5. So we can let each tick length have a unit length of 1. So we'll do a 5 to -5. So our first ordered pair is at 5 or +5. So 2, 4, 6. We've gone too far. So we'll go back right about there is 5 and going down 1, 2 units. And our second point is 9, -5. So again, 2, 4, 6, 8, 10. So right in between 8 and 10 is 9. And we're going down 5 units. So connecting those 2 points, we can see our line segment. So now that we have sketched a graph of this line segment, we're ready to find the distance between the endpoints. So in order to do that, we need to recall the distance formula. So plugging our given endpoints into the distance formula, we can find the length of our line segment. So we have d is equal to this big old square root of the change in our x values. So we have 9 minus 5 squared plus the change in the y values. -5 minus a -2 squared. Now looking within this square root, we see we have a negative times a negative, which produces a positive value. So we're left with the square root of 9 minus 5 leaves us with 4 squared plus -5 plus 2 gives us a -3 squared. So we have the square root of 16 plus 9, which gives us the square root of 25. Now, we can simplify this a little bit further. Since we're working with a square root, we want to look for perfect squares within the factors of 25. And in fact, we know that 25 is a perfect square. We know that 25 is equal to 5 times 5. So we can simplify this to the square root of 5 squared. And at this point, the square and the square root are going to cancel each other out, leaving us with a distance of 5 units, making that our beautiful final answer.